8 o'clock. Let's see. I forgot to record yesterday in your class, so there no recording from yesterday. The notes have been posted. Okay, so I'm recording now. I have graded your exams. I have not returned them yet. That's another couple of hours of work. They're pretty good, I'd say, overall. A couple of people made 100 flat out. Fair number of high grades. Some people did not do well, of course, and some people were in the middle. But I have posted the exam solutions on Blackboard. So if you want to know whether you got things right or not, you can look. And I should have those all returned to you today. What else? Homework due tomorrow. Oh, and I checked about the fall break thing. It is still on, so there will be no class Monday and Tuesday. Okay, we have fall break, so nice break for all of us.
No class Monday and Tuesday of which week?
Next week.
Oh, next week we're not having class Monday and Tuesday?
Yeah, it's on the university calendar, and I was wondering that since we missed some because of the
goodness.
Huh?
I said, oh goodness.
Okay. Yeah, your audio is fading in and out. Yeah, I was wondering, we had to miss some days because of the hurricane. So what is it still beyond? But yes, it is. Okay, let's see. Any questions about anything? Okay, I want to spend one more day on curve sketching. And today, we're going to look at an example of a periodic function, okay? Okay, let me get my notes out. All right. And okay, so let's graph the function f of x. My pen's not working. Oh dear. No, all right. Let me recharge it a minute here. Dock it. Yeah, that worked. All right. Okay. So f of x is 2 cosine x plus the sine of 2x. And this function is periodic of period 2 pi. Because both of the functions involved are periodic of period 2 pi. I don't need that, do I? Just to show you, if I put 2 pi in for x, or x plus 2 pi, that's equal to 2 cosine of and that's equal to, well, I have to use the cosine of the sum of two angles and the sine of the sum of two angles. Oh, so this is 2 cosine of x, if I remember these correctly, cosine of 2 pi minus sine of x times the sine of 2 pi plus, using trig identities, plus the sine of, it's really 2x plus 4 pi. And I have to remember. Okay, what I do is remember the double angle formulas, and then I go from there. Okay, so this is going to be the sine of 2x cosine of 4 pi plus the sine of 4 pi cosine of 2x. Now, if I remember these incorrectly, I'm going to have to go back and change this. Okay, well, let's see. The sine of 2 pi is 0. Sine of 4 pi is 0. And the cosine of 2 pi is the cosine of 0 is 1. So this, that's 1. Did somebody enter the waiting room?
Yes, ma'am.
Okay. Okay. And then this, okay, the cosine of 4 pi is 1. So you just, that's 1. So that's just, there's no 2 there. That's just the sine of 2x. Okay. So, and that's equal to f of x. So that shows then that that function has period 2 pi. And that means, for one thing, that I only need to figure out what happens on the interval from 0 to 2 pi. And I get my graph, and then I just translate, move it over 2 pi, move it back 2 pi, and so forth. Because the same thing is going to happen on every interval from 2n pi to 2n pi plus 2 pi. Okay, and also domain of this function is all the reals. Okay, because the sine's defined for all reals and the cosine is defined for all reals. In fact, this function is continuous over all the reals. That means, for one thing, there are no vertical asymptotes. Okay. A function that's continuous on the entire real line has no vertical asymptotes. Then we do not have to worry about that. It also has no horizontal asymptotes. But not because it's continuous. It has no horizontal asymptotes because it's periodic. And not just equal to 0 or something. And not just constant. Yeah, a constant function is periodic. Constant function is a boring function, but it is a function. Constant functions are periodic. And if you have a constant function, so just a horizontal line, you have a horizontal asymptote, which is that line. But that's the trivial case. Okay. This is not, our function is going to be more interesting than that. Okay. So we know it's periodic of period 2 pi. We know that it's continuous over all the reals. We know it has no asymptotes. What about, let's see, while we're here, before we take derivatives, what about the x and y intercepts? That's useful information. The y-intercept That's where the function crosses the y-axis, where you just look at f of 0 and, okay, that would be 2 cosine of 0 plus the sine of 0, which is 2. So it's got y-intercept of 2, and then x-intercepts. Sometimes x-intercepts are really hard to find. In this case, they're not. But if they're really a pain, I usually either hold that until the last or don't even bother with it. Because if you get all your other information, it's usually adequate to give you a good idea of what the function is doing and what the graph looks like. And maybe it's enough to know that you do have one and approximately where it is. Okay, so x-intercepts, that's when f of x is equal to 0. Okay, this is places where the graph's going to cross the x-axis, and that says that 0 is 2 cosine of x plus the sine of 2x. I have to keep going back and check I'm writing the function down correctly. Okay. I think this would be easier if I used a trig identity, namely, well, I kind of wrote it up there before. The sine of 2x, this is called one of the double angle formulas. Sine of 2x is 2 sine x cosine x. Okay, so this is 2 cosine of x plus 2 sine x cosine x. And, okay, so of course I put that right out in the middle there. I can factor out 2 cosine x from this expression, and that gives me 2 cosine x times, oops, 1 plus the sine of x. Okay. Yeah, again, whenever something's equal to 0, you want it written as a product. Because that says that either 2 cosine of x is 0 or 1 plus the sine of x is 0. And then, well, solve them individually. So this one says cosine of x is 0. Where does the cosine equal to 0? It happens at odd multiples of pi over 2. In fact, at an infinite number of places. Minus pi over 2, pi over 2, 3 pi over 2, ... Okay, we're going to focus on those two mainly because in a minute we're just going to look at the interval from 0 to 2 pi and then translate that using the periodicity. And this says that the sine of x is minus 1. Well, that happens, let's see, sine at 3 pi over 2. And 7 pi over 2 at an infinite number of places. But okay, but notice that these numbers are a subset of those numbers. So x-intercepts all the odd multiples of pi over 2. Okay, so we have, that's kind of our non-derivative information, just out of the function itself. Any questions so far? Can y'all still hear me?
Yes, ma'am.
Okay, good. After Monday, I'm going to keep checking. All right. So now let's focus on just one period, right? So I get my picture of what happens from 0 to 2 pi, and then I just keep repeating, okay? That's kind of the idea. If I know what happens on 0 to 2 pi, I know what happens on the real line. So it's like you have a template and you just keep moving it over 2 pi units. All right, so now for our derivative information. No. Oh, no. Y prime info. And this is going to tell us about increasing, decreasing, and local minimum and maximum. Okay, so we need Y prime first, and let me write down Y. Also, okay, I'm going to try to stick with black. It seems to appear better on the notes. Yeah, those PDF files I get out of this iPad, they're not of terribly high quality. You can read them, I think, but try to make it as nice as possible. Y prime info. Okay, so F. Oh, I did it again. F of X is the 2 cosine X plus the sine of 2X. So F prime of X is minus 2 sine of X plus the cosine of 2X times 2. Now, I kind of did all that. Well, that requires a chain rule, that sine of 2x, right? Because the inside function is 2x. The outside function is the sine. So it's the derivative of the outside function, which is cosine, applied to the inside function, times the derivative of the inside function. That's where that extra 2 comes from the chain rule. Okay, so we have, let's see, f prime equal to minus 2 sine of x plus 2 cosine of 2x. And that's always defined. So no critical numbers from f prime not being defined. Where is it equal to 0? We need to know those to know where possible changes from increasing to decreasing or vice versa can occur. Okay, so that means I want to set minus 2 sine of x plus 2 cosine of 2x equal to 0. And again, that cosine of 2x, a little bit of a problem. The sine and the cosine aren't linear, remember, which means you can't just take cosine of 2x is not equal to 2 cosine of x. But there's another set of formulas, double angle formula. The cosine of 2x, well, there are 3 ways you can write it. Cosine squared minus the sine squared. Or if you replace cosine squared with 1 minus the sine squared, that would give you 1 minus 2 sine squared. Or if you replace sine squared with 1 minus the cosine squared, that would give you 2 cosine squared of x minus 1. I'm checking. Okay, thinking, making sure. You know, my memory for mathematics is sort of strange because it's all stored as relationships. Okay. And I have to kind of think about things. If you see an error, please let me know. I think maybe this is the one I want to use, this form, because then everything will be in terms of signs up there in the derivative. With that, okay, f prime of x then is minus 2 sine of x. And I'm going to replace cosine of 2x with 1 minus 2 sine squared of x. And I want to find when that's 0. So that gives me, let's see. I'm going to write the squared term first. Minus 2 sine squared. No, minus 4, right? 2 times minus 2. And then minus 2 sine x and plus 2. That's equal to 0. Let's see, I may as well clean out those coefficients. I can divide out, how about I divide out a minus 2? So that would give me 2 sine squared x plus the sine of x minus 1. Divide out minus 2. And then because it's minus 2 times something is equal to 0, you can, okay, 0 over 2 is 0. So that goes away. Okay. Well, that's in terms of sine of x, but does it factor? It's got to be, that's got to be 1. And I want that to be a plus. So maybe like that. And let's check. Okay, get 2 sine of x minus sine of x is plus sine of x. And then minus 1 and 2. Yeah, I think that works. Okay, so I have written this as a product because that makes it easier to find where it's equal to 0. So now this says that either 2 sine of x minus 1 is 0 or sine of x plus 1 is 0. And, okay, again, so this is sine of x is equal to 1/2 or sine of x is equal to minus 1. Now remember, we're just kind of restricting ourselves here to this interval from 0 to 2 pi. There's only one place in that interval where the sine of x is minus 1. And that's at 3 pi over 2. Sine square x equal to 1/2. Well, that is not sine squared. Sine of x is equal to 1/2. That happens at pi over 6, right? That's a special angle. And that is the square root of 3. And of course, yeah, I remember this little right triangle. And that tells you about all the trig values of pi over 6 and pi over 3. Okay, so one possibility is pi over 6. And where else is the sign positive? Well, it'd be positive in the second quadrant. So that's going to say x is 5 pi over 6. Okay. Yeah, for, what would it be? For 7 pi over 6, the sign is negative 1/2. And for 11 pi over 6, it's negative 1/2. So these are all the places then where we have the derivative equal to 0. So our critical numbers let's see if I can write them in order. increasing order, pi over 6 and then 3 pi over 2. No, that's not right. Okay. Sorry. 5 pi over 6 would come next. And then 3 pi over 2. Okay. So, well, I'm only checking one piece here. So let's see, critical numbers. Pi over 6, 5 pi over 6, and 3 pi over 2. And this is my y prime line. Okay, so check intervals. Well, okay, how about 0? I can check 0. It's easy. Okay, here's where I need to remember what f is. No, I don't need to remember what f prime is. Okay, so f prime is, I'm writing it just so I can have it sitting in front of me here. F prime, and again, I'm gonna leave it in factored form, 2 sine okay, well, I factored out a -2. Is that gonna make a difference? It doesn't make a difference for the 0 part. But I better put it back I'll put it back in here. There's a -2 sitting in front of everything. F prime of x is -2 times 2 sine of x minus 1 times sine of x plus 1. Yeah, because that was actually f prime. Okay, 0. Well, the sine of 0 is 0. So, and that's going to be -1 then. Sine of 0 is 0. That's -1 plus 1. So -1 times -2 is plus. And that's really all I care about. I got a plus for the derivative at 0. So that means that the graph is increasing there. Okay, and then between pi over 6 and 5 pi over 6, well, pi over 2 is in that interval. And let's see, so sine of pi over 2, well, let's put it, look. So it's going to be -2 times sine of pi over 2 is 1, so 2 minus 1. Sine of pi over 2 is 1, 2. That gives me a negative. So decreasing. And then, okay, what's the number in between 5 pi over 6 and 3 pi over 2? Well, pi's in there. I can use that. And let's see, that's going to be -2 times -1 times 1, which is +2. So plus. Oh, I like to do that in blue. And then finally from 3 pi over 2 to 2 pi. Well, how about I just use 2 pi? And well, that's going to give me the same thing that the 0 did because of the periodicity, right? Is this still? Well, let's check it. Yeah, I think this is periodic too, but I want to be real careful. All right, so if I put in pi minus 2, 2 pi is 0. Yeah, that works fine. Okay, so I get plus, still increasing, and then that means the function is still increasing. Okay, so what do we have? I guess I need all that. We have that f increases, and actually it's increasing from 3 pi over 2. Well, it's this. Okay, let's keep it simple. 0 to pi over 6 and 5 pi over 6 to 2 pi. F decreases on the interval from pi over 6 to 5 pi over 6. And let's see, we have a local max, and a local min, which means we're going to have an infinite number of them, because remember, I'm just doing one period. A local max, okay, abbreviation for local maximum, is going to be f of pi over 6. And the local minimum is going to be f of 5 pi over 6. And let's see if I can remember what f is. F of x was equal to 2 cosine x plus the sine of 2x. So f of pi over 6 is 2 cosine of pi over 6 plus the sine of pi over 3. And that little triangle is helpful. The cosine of pi over 6, okay, is the square root of 3 over 2, just looking at this. And the sine of pi over 3, okay, well, there's pi over 3, so that would be opposite over hypotenuse. That's the square root of 3 over 2, too. And so that's equal to 3 over 2. That 2 goes away. And the square root of 3 times the square root of 3 is 3. Have I missed something there? Oh, I certainly did. Oh, geez. I turned a sum into a product. Oh, dear. No. Okay. Let's see. I should have left more room. So let me just erase this for the moment. I hate scrunching things up. Okay, so local max. Okay, the cosine of pi over 6 is the square root of 3 over 2. Plus the sine of pi over 3, which is also the square root of 3 over 2. So that's the square root of 3. 2 square roots of 3 over 2 plus 1 square root of 3 over 2 is 3 square roots of 3 over 2. There, I think that's better. That's the local maximum. Okay, and then local minimum is f of 5 pi over 6. And that would be 2 cosine of 5 pi over 6 plus the sine of, okay, 2 times 5 pi over 6 would be 5 pi over 3. Okay, so the cosine of 5 pi over 6, well, the cosine of pi over 6 was the square root of 3 over 2. 5 pi over 6 is in the second quadrant, and in the second quadrant, cosine is negative. So this is going to be 2 times minus the square root of 3 over 2. The sine of 5 pi over 3, 5 pi over 3 is in the fourth quadrant. Excuse me. Okay, fourth quadrant, so that means the sine is negative. And that means I'm going to get minus the square root of 3 over 2. So this is minus 3 times the square root of 3 over 2. Local minimum. Okay. So we have all our first derivative information. And let's just start plotting. We're going to refine the plot with the concavity information. But now I have a crude idea, at least. Well, I'm only going from 0 to 2 pi. But let's see. I know my y-intercept was 2. X-intercepts pi over 2 and 3 pi over 2. Is that right? Oh, this is where I miss a blackboard. I could just look over to the other side instead of going back. Okay, so let's see. That's kind of, so pi over 2 and 3 pi over 2. Those are x-intercepts. Okay, only ones between 0 and 2 pi. And in fact, I know what the f of 2 pi is because the periodicity is 2 pi. It's got to be the same thing as f of 0. Okay, so, and then we have a local minimum at 5 pi over 6. Where's that? That's about right here. 5 pi over 6, but it is minus 3 times the square root of 3 over 2. It's less than 3, or minus 3. Doesn't quite get there. Okay, so I'm going to call that minus 3 times the square root of 3 over 2, and I'm going to call this plus 3 times the square root of 3 over 2. So that's 5 pi over 6. That's right there. Okay. And okay, that was 5 pi over 6, and pi over 6 gave the local max. And that's right about there. So that's that. Okay. Okay, so the graph, now this point, that point, and that point, those are not part of the, that's not an not an intercept. Okay, draw my axis back. Okay. So the graph up, down, up, basically. Okay. Now this is crude. I don't have any of the concavity included in this. But that's what you get out of first derivative. And we have the crude shape. Okay, any questions so far? Can you still hear me?
Yes, ma'am.
Oh, good. Oh, good. Oh, and no, but the periodicity, well, we just did the 0 to 2 pi, but I'm going to have the same picture over here, right? It's going to come down, go up, and come back. So yeah, this picture is going to keep repeating. And something over here. But yeah, if we can get what happens between 0 and 2 pi, we can just pick it up, move it over, yeah, pick up the template and move it over 2 pi units and stamp that in and whatever. Okay. These things take some time. That's all there is to it. Of course, I'm kind of going into a lot of detail here too. All right, but we're finally ready to look at y double prime. It's supposed to be double prime. Okay, so first of all, I need my second derivative. And let's just go back. Let's see. F of x was the 2 cosine x plus 2, the sine of 2x. So f prime minus 2 sine x plus 2 cosine of 2x. And f double prime then is minus 2 cosine x minus 2 sine 2x times another 2, which is minus 2 cosine x minus 4 sine of 2x. Okay, checking that. All right, there's f double prime. And okay, f double prime is always defined. So I don't get any critical numbers that way. Where is it equal to 0? Okay, so again, I need to write this as a product. But don't write it as a product. It's going to be hard to find all the places where it's equal to 0. You may get some, but you may miss some too. And if you miss some of these things, you miss important places. Okay, so I'm going to use the double angle formula again. Sine of 2x is 2 sine x cosine x. And that changes me to, let's see, both terms here have a factor of cosine x, and both terms have a factor of minus 2. So I can factor out minus 2 cosine x, and that would just leave me with 1 from the first term, and from the second term, okay, that went, and 1 minus 2. So I still have a plus 4 sine x left. Okay, and that looks better. I don't know where the sine of x is equal to minus a fourth. Okay. Just have to kind of eyeball that. All right. What does this say? I want to, yeah, that's not going to give me a special angle. Doesn't mean it doesn't have a solution. It just means it's not one of the I can write down exactly. Okay, so this says that minus 2 cosine of x is 0, or 1 plus 4 sine x is 0. So cosine x is 0. Well, that happens at pi over 2 and 3 pi over 2. Still, we're just kind of looking at this one period, 0 to 2 pi. And this other one says that for sine x is minus 1. Sine of x is minus 1/4. Well, that would give me, there are two places. Okay, unit circle. Sine of x is negative in the third and fourth quadrants. So there is a solution in the third quadrant and there is a solution in the fourth quadrant. And okay, you can pull out your calculator and get an approximate value. And remember to do radians and not degrees. But I'm just going to use the fact that there are, okay, two values. That's minus 1/4. You can't see that. Okay. Minus 1/4 for y. There. Okay, so there are two values. I'm going to call one A1 and the other one A2. Okay. And A1 is between pi and 3 pi over 2. And A2 is between pi over 2 and 2 pi. Okay. Okay, so I know where these, well, yeah, I can still get a pretty good idea. This, so A1 and A2 are both bigger than 5 pi over 6. So I know kind of where they are relative to my local minima and maxima and the critical numbers from the first derivative. Okay, so call that pi. So 3 pi over 2. A1 somewhere in here. A2 somewhere in here. Okay. And I'll just put, so yeah, 3 pi over 2 right there. And pi right there. And I can use those to check my intervals actually. Okay. Yeah, so the only places where the second derivative can change sign, SIGN sign, is at this number A1 or the number A2. And I'm checking this as Y double prime now. Y double prime we're looking at. We're getting concavity information. Okay, and so pi is between 0 and A1. Can use that. And where did my second derivative go? Okay, it was minus 2 cosine x times 1 plus 4 sine x. Okay. Almost out of time. Each problem.
Dr. Kennedy?
What?
Yeah. When you factor, I think when you factored f double prime, yeah, right there, if you can stop. Yeah, that should be negative 2 cosine x times 1 plus 2 sine x.
No.
Right?
Okay, there's a 4 and a 2, so that's really an 8. Right?
Well, no, it wasn't f prime negative 2 sine x plus 2 cosine x 2x.
Okay, let's go back, start. Okay, first of all, do you agree that, thank you for checking me, please. Yeah, please do. I miss stuff all the time. Okay, isn't f double prime to start with minus 2 cosine x minus 4 sine 2x? Did I do that
Yeah.
right? Okay, so what am I doing next? I'm replacing sine of 2x with 2 sine x cosine x. Right, and there's a minus here and a minus there. But now I have this extra 2. So this is really minus 8 sine x cosine x.
Okay, yeah, you're right. I'm sorry. I was just trying to figure out where that
No,
1/4 was coming from.
right. Well, I wish it were a half. Okay. But thank you. Please do check me. Okay. So it's so much nicer to find your error early on before you mess up the entire problem. Okay. All right. So we were checking intervals. Let's see. At pi, well, the cosine of pi is -1, right? Cosine, yeah, it's -1. So that's -1 times -2. That's a plus. At pi, well, sine is 0, so that's gonna be a plus. So that's going to give you a plus overall. Concave up. Okay. Between A1 and A2, well, 3 pi over 2 is in that interval. And okay, so cosine of 3 pi over 2 is 0. Uh-oh, that's not supposed to happen. Oh, wait. Yeah. I forgot entirely about those two. Oh. So my number line, okay, you don't want to miss these. Let's just start over. And I have like 3 minutes left. Okay, well, we'll kind of finish this up again. I was going to do some now, but I'll talk about this last part again tomorrow. Well, let's put a number line with all the numbers on it. How about that? Okay, so pi over 2. Let's kind of tick it off with relation to. Pi over 2 and 3 pi over 2 are critical numbers. And then I have 2 more. This A1 between pi and 3 pi over 2, because this number is pi, and A2 between 3 pi over 2 and 2 pi. All right, so there are more intervals to check. There's 1, 2, 3, 4, 5 intervals to check. And there's no way I'm going to finish that right now. Okay, so we'll pick up here tomorrow. and finish this one problem. So we've done, let's see, well, once I finish this problem, we've done a polynomial. We've done one with the roots. Okay, the root ones, they tend to have these places where you have the critical numbers, where f prime or f double prime is not defined, but the numbers are in the domain. So sometimes yes, sometimes no. And you get these cusp or corners on functions where those derivatives don't exist. We also looked at a problem that had vertical and horizontal asymptotes and numbers that were not in the domain. And we're looking at a periodic function. So it kind of gives you a fair variety there. I think I spent basically 4+ days on this. So tomorrow will be the last day. And in fact, I'll start going on to something else, which would be optimization problems tomorrow. Okay. But yeah, these problems take time. If you work them out carefully, they take time, and you have to reason it all out and make sure your information matches. You know, if you get things that seem impossible, maybe it's because you made an error. Anyway, we will stop there. So I will see you guys tomorrow. Class is over. Stick around for a minute if you have a quick question.
Have a good day.
Bye.
You too.